Okay, if you're looking at your homework, I'm going to try to zip through this quickly. You had 5 questions to answer. So these are the answers, and I'm going to just explain the reasonings behind each. Number 1, Mikey tosses a coin 50 times. The coin shows 28 heads. Heads 28 times. What is the fraction of heads? So that's 28 heads over 50 total tosses, right? So if you know that, you can create that fraction of 28 heads out of 50. And then you can just change that to a percent by using your change to percent sign. All right, 56%. So there's number 1. 1A. 1B. Suppose the coin is fair and Mikey tosses it 500 times. How many times would you expect? Now, we talked about expectations. Expectations are before you actually do it. It's theoretical probability. So your expectation is that half the time you get heads and the other half you get tails. So if you apply that and you say, I tossed the coin 500 times, then you should expect 250 times because of expectation. That is before experimenting. So half of the 500 is 250, as you can see right there. Okay? Number 2 says Calvin tosses a coin to determine his breakfast cereal every day. He does this from his 12th birthday to his 18th. So if you go from his 12th birthday to his 13th, that's 1 year, to his 14th is 2, 15th is 3, 16th is 4, 17th is 5, and up to his 18th birthday, that's 6 years. Got to be careful with that. You don't want to go 12, 13, 14, 15, 16, 17, 18, and get 7 years counting his 18th birthday. So you got to be careful. 6 years. A couple things you need to know. There's 365 days in a year. At 6 years. To do that math, you simply do 365 times those 6 years. It means there's 2,190 days in those 6 years, okay? And then from there, you can make an expectation, just like we did before for the 500 coins. I expect half of those days Calvin to win, and the other half is Mom to win. So half of those days, half of 2,190, it's 1095. So that's how many days you would expect Calvin to eat his type of cereal. Number 3, it says Calvin tosses a coin 5 days in a row. He gets tails every time. I demonstrated this. He gets heads every time. What are the chances it's going to be tails? Well, the chances it's going to be tails is 1/2. Sorry, I'm blending 2 questions. Calvin tosses a coin 5 days in a row, gets tails every time. Do you think there's something wrong with the coin? The answer is no. I don't think anything's wrong with the coin. But there could be. The only way to find out is toss it more times. Okay, if you keep tossing it and you get a heads, then nothing's wrong with the coin. It's just luck, all right? 5 times in a row, tails. It's just lucky. You would expect the next 5 to be heads or tails, whatever. All right, so that's number 3. Number 4, same concept. Len tosses a coin 3 times, and it comes up heads, heads, and heads. What's the chances it shows tails on the next try? What's a 1/2 chance? Every single time it's a 1/2 chance, because every time it's 1/2. It's independent. We learned that term. Okay? Independent means it doesn't depend on the previous time. All right? Number 5, is it possible to toss a coin 20 times and land heads up? Yeah, that's possible. You can't say it's impossible. It's not impossible. There's a chance for that to happen. But is it likely? We talked about that percentage. Is it likely? No, certainly not. That is not a likely event to happen. So if you were gambling on that, you wouldn't say, I expect it to come up 20 times in a row, heads. You wouldn't bet on that, right? It's unlikely for that to happen. It should be 10 heads and 10 tails. That's your expectation. It's unlikely for it to be something so crazy as 20 in a row. All right, so that's it. Oh yeah, and by the way, all of you that owe me $1, put it on my desk. Yeah, later.